Coming up on this episode of the IoT Inc. Business Show.
If I could define descriptive analytics, it basically is reporting what happened and what's happening now. And the data that you see that descriptive analytics packages pull from is everything that we have stored in our data warehouses, in our relational databases, structured and unstructured data. You know, it's the things that we're sourcing now in every type of sensor in a connected environment.
Descriptive analytics is nothing new. However, IoT is applying evolutionary forces to make it adapt to unstructured sensor data and evolve into a mechanism of discovery rather than report generation. Tools that blend traditional business intelligence, analytical modeling, and visualization now help data scientists discover the story behind the data, which can lead to valuable insights for the enterprise. In this episode of the IoT Business Show, I speak with Dave Rubal about how to apply descriptive analytics to your Internet of Things.
All this and more on this episode of the IoT Inc. Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc. Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc. Business Show. This show is made possible by sales of my book, IoT Inc., published by McGraw-Hill, and the IoT Inc. Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 27 is Dave Rubal. Dave is Director of U.S. Federal Systems Engineering at Blue Coat Systems. He has over 35 years of experience in telecom, networking, security, data science, and analytics, and has extensive experience in IPv6, which is where we originally met. Although his current focus is on cybersecurity, today we're going to talk about analytics, and in particular, descriptive analytics. Dave, welcome.
Thank you. I'm glad to be here.
So I understand you were recently at a pretty interesting event. What was it?
Yes, that's the annual event, the annual cybersecurity community event that focuses on the hacking space and vulnerability space. Black Hat USA, held in Las Vegas this year, and always well attended and growing every year with every cybersecurity breach, with every data breach you read about. Cybersecurity becomes more top of mind for everyone. So, the Black Hat event is an annual event. It's a lot of focus on prevention, detection, mitigation, and then also that hacking aspect.
Yeah, sure. Now, what about IoT? I mean, has it raised up on the radar, or is it still pretty much in the weeds?
Absolutely. From a IoT perspective, as a matter of fact, one of the examples that you can see from the Black event was the Tesla hacking event.
That's right. Yeah, I read about that actually. Yeah, that's right.
Yeah, and so from that and in that community, you've got a concentration of people that are very talented at being able to determine where vulnerabilities are and exploit them. And one of the areas that they actually demonstrated was the ability to hack connected cars. And then throughout the event, there were different examples of IoT-related aspects in terms of hacking through and creating vulnerabilities, exploiting vulnerabilities in robotics, some of the industrial systems, some of those connected systems that we all have to deal with and that we all have now.
Yeah, and I'm interested in this and not to go too far down the line, but I guess number one, just to clarify on the Tesla, I believe it wasn't remotely hacked. I think you needed to be in the vehicle. And then secondly, for the IoT, what are you seeing as being, what are the major areas of vulnerability? Is anything percolating up there? Is there any, I guess, themes coming through on the IoT side?
And so absolutely. From an IoT perspective, one of the realities that the community is coming around is that, like many other aspects of infrastructure technology, IoT requires security, and it requires the ability to ensure that regardless of where the device or what the device type is that's connected to any type of network, that it's operating in a secure means and that it doesn't create additional levels of vulnerability. That's some of the learning that's still happening. It's still an emerging topic. And it's an interesting push-pull because at times the great things that the Internet of Things brings in terms of capabilities, that and securing it and sometimes locking it down are two different agendas.
Mm-hmm.
So right now it's more focused on the capabilities associated with IoT and kind of emerging into the security space, but how to actually secure it in a broad and national and global fashion. So there's still some more work to do there, and it's an emerging area.
Yeah, definitely. And I guess something that bothers me, and I guess I could be somewhat considered media as well, but just the media's focus on, the hype around, not the hype I should say, but there's the scare tactics, using scare tactics to get their stories read. And often they're around security. And, let's be honest. I mean, yeah, of course there's going to be security issues with IoT. There's no doubt, just like there's security issues with IT. However, they're no more, or maybe I should just say they're just different. It's not like they're any more susceptible than, say, other network systems, like you're just saying. Or do you have a different view on that?
Well, so it's an interesting paradigm, Bruce. With the possibility of the number of devices in the IoT space compared to traditional static enterprise, the enterprise world, and that includes even through service providers serving millions of homes globally in different scenarios. IoT is a bit different because it changes that dynamic pretty seriously. Now we're talking about millions and trillions of endpoints as opposed to thousands.
Sure.
So what it does is it impacts the policy of everyone from companies that are trying to hire and recruit people and actually from a workforce perspective encourage the use of these technologies and actually use these technologies for their business objectives, and in the case of government to achieve mission success. And then from the service provider perspective, with mobile devices in everyone's hands these days, smartphones and tablets and everything else, the reality is that need will continue to grow. And I don't know about you, but you look in your bag and all of a sudden you realize how many connected devices and between that in your car and everything that you use on a daily basis, that number is increasing. So it is a new attack vector for us from a security perspective. It's something that has to be dealt with, and basically understanding more about the way that IoT technology is being used, for what reason, and from a data management and infrastructure management perspective, the implications associated with it are key. I know there's a lot of work being done there now, and actually brings us to our topic here around the use of analytics in that space.
No, I mean, and I think we could dig into this, and this, I guess, for our listeners, is going to be a precursor to a number of podcasts that are coming up. But yeah, why don't we shift? I mean, because I think we could spend the whole discussion on this. But yeah, let's shift it. Why don't you bridge it, analytics and security? Because I think I know where you're going with this, but it's pretty cool.
Sure. Well, so it's an interesting new intersection, Bruce, and the Internet of Things actually brings this topic to light around the need for better insight into data and the better insight into the types of situational data that's many times sourced and created on a very regular basis by everything from wearables to mobile devices to endpoints in the Internet of Things that may only live on the network for a few minutes or a few seconds. So it changes the dynamic in the way that we think from a architectural perspective, from a design perspective, and really from an ongoing management perspective. The analytics piece here is particularly interesting, and really to start, we'll look at probably the simplest of the analytics along the business analytics continuum, the descriptive analytics area. But if you look at the entire continuum itself and really how it applies to the Internet of Things, from the current state and what's happened in the past, descriptive, the diagnostic aspect, and then what's happening in the future in terms of making some predictions and forecasts and trends in the predictive and the prescriptive area. The Internet of Things is actually going to force us, of any of the recent technologies, force us to think differently and actually use and exercise all elements of the business analytics continuum.
And so, just using an example, I guess the one that comes to mind is using analytics to recognize actions that are anomalies that you could then maybe focus a little bit more attention on. I mean, what are the big ones? What are the big ones if we just talk about that union?
Yeah, so there's, particularly in the area where, from an analytics perspective, looking at what's happening now or what's happened. The data mining aspect once the data creation occurs, and then being able to effectively make some sense of the data and then apply it. This takes on different forms, whether it's structured data or unstructured data, and making the determination about how best it can be represented. A lot of times, data visualization tools that you see out there, whether they be traditional business intelligence or business analytics tools, start to leverage the descriptive aspect of the analytics model so that they can kind of freely pull the data at its source and then start to come up with a correlation of data. Look at those areas where there's traditional alignment, or maybe start to create some environments where, in the case of the Internet of Things, joining some of the sensor data with enterprise data. So, the social media falls into this pattern as well. So as we get further down the wearable path and start to incorporate and create new intersections with social media, that type of data that's captured from the source can be useful in a number of ways as we get further through the model.
Yeah, and then tying this into security, what you're saying is, using the visualization to perhaps in real time see what's going on with your network, if it's an industrial application, or in the case of the wearables, perhaps using it to see, oh gosh, this wearable is not where it should be, and so potentially there's a security problem here.
Sure. Well, and from a security perspective, relative to the use of analytics and kind of at that new intersection, it does provide key visibility in the way that sensors and sensor technologies are used, and active devices that are data creation elements. And from a security perspective, some of those things may be a source or a feeder into a larger situational awareness situation. So in the case of critical infrastructure, in the case of government services, even right down to military operations and warfighter capabilities. The need for security at this level and at all levels, as we're discussing, is actually representative of the opportunity here to open up a technology for use, but at the same time make sure that it's not creating any additional risk or any risk that can't be controlled or mitigated.
And looking at it another way, more in, from a positive perspective, I think it's also using technologies like analytics to improve, on security that we perhaps didn't have in the past.
Absolutely. So, in particularly around the descriptive aspect of the analytics model. If we can look at where data is sourced and for what reason and how it applies to security policies, it actually does feed into higher level security decisions and security insight. That without that data enabled model, it's actually hard to pull from many sources and to be able to come up with some decision about behavior or relationship or state or status at any point. So definitely the analytic model feeds those types of concepts and feeds the ability to provide kind of a wider and broader sense of the risk associated with any particular aspect at any one point.
Yeah. Well, let's circle back and start at basics. Today we're going to talk about descriptive analytics. Of course, we can talk about any types of analytics and more security at any time. But why don't you start with defining descriptive analytics? Give us your definition, and we'll take it from there.
So, if I could define descriptive analytics, it basically is reporting what happened or what's happening now, and the data that you see. That descriptive analytics packages pull from is everything that we have stored in our data warehouses, in our relational databases, structured and unstructured data. It's the things that we're sourcing now in every type of sensor in a connected environment, whether it be unstructured data or structured data. And structured data being columns and rows, and unstructured data maybe being a log file or maybe video. Right. Those are all examples of data sources. As we go further into the continuum, the diagnostic aspect is now taking that collection and that data mining aspect of analytics and now kind of slicing and dicing it to find out why. So we can start to ask some more of those iterative questions at that point. Start to look at the patterns and where the lines cross, if you will. And then as we go further out and start to then look at the effective and proactive use of the capture of this information and maybe the joining of different sources, different types of data, as we've described here, the predictive and the prescriptive pieces really become important. So now we can forecast based on patterns that are detected in that data, in that source data. And then from a prescriptive perspective, we can then apply knowledge to affect change from that data. So that's really a good example of the entire analytics or the business analytics continuum in motion.
Yeah, no, I like that. And two things I want to pick up on. Number one is you kind of identified it. You mentioned it earlier, but that is combining sensor data with other information sources or other data sources. I think you use BI as an example, but there obviously is a whole bunch of other ones. And the second thing is I like what you're saying is basically just is asking why, discovering patterns, where lines intersect. What are the techniques that are used to do that at a high level? And then we can maybe, I think visualization is obviously one of them, but what are some of the other techniques that help us help us answer the whys and see the patterns and as you say, where the lines intersect?
Sure. Well, even from a fundamental perspective, Bruce, looking at the source of the data, as we capture the data itself and every aspect of the creation of data is handled this way. There's the source data, the ones and zeros itself, and then there's the metadata associated with it. The metadata describes the data that's being stored, if you will, or the data that's being sourced. And so the valuable piece of that sourcing is actually in the metadata. So from there, we can make some decisions about types of data. We can make some decisions about potential intersections and potential areas where data relevance could be determined. And really in that descriptive and diagnostic area of what's happened, what's happening right now, and start to formulate those patterns, that's the area typically where traditional business intelligence, business analytics packages, and data visualization come into play, and looking at that history, looking at those indicators, and really from the metadata that's created from the source data, again, whether it's sensor or static data or some combination of that, that it can literally be, or social media data, or behavioral data, or relationship data, marketing data. The list goes on and on. And whether it's big or small too. There's a lot of conversation as you see, and as many people look at. It's a buzzword for big data analytics. That the reality is that data, both big and small, is important. And the fact is, the majority of the data that you have sourced in the enterprise environment, and particularly in the IoT space, is small data. And just that when we come to the storage aspect and the larger analytics aspect, that's typically when it gets labeled big data, because now we're talking about, relational databases with, instead of hundreds of rows of data, maybe millions or billions. So is it big? Absolutely. It does change the paradigm, and it does require different thinking about how to process that data from the processing aspect to high performance processing. But at the end of the day, from the analytics perspective, we need to look at all types of data, large, small. We need to look at the variations of data, whether it be, the characteristics, as I mentioned earlier, structured or unstructured. And all of these have different aspects of consideration as we're stepping into the IoT evolution. Because there are sensors and there are technology that, as I mentioned earlier, live on the network for a few minutes, and some that are core and critical to the ongoing real-time state status, information gathering or information creation that's needed by that device.
Well, yeah, no, and so I think this is a good opportunity to kind of provide some clarification, and specifically around big data and small data. One way to look at it is, for IoT anyway, this is timestamp data, so you're going to have a number of columns, and this will be, all the sensors in a group, or all the sensors that are being collected, and then the rows being, I guess you can think about it in a bunch of different ways, but the rows being potentially the time. So maybe one way to define big and small data, I don't know, is it the number of rows? And so it's a bunch of small columns with a bunch of rows, or is it that it's a really long, a lot of columns? But then you bring up another interesting, way of maybe looking at it as well, and maybe you can contrast the two. But real time versus non-real time. And real time, again, maybe that implies the time dimension, and so you've got a bunch of rows. But so maybe, big data, small data, you brought it up, and I think it is worth investigating a little bit further. What is the definition, and how do we kind of put our heads around this?
And so to that point, the types of data, particularly in the structured environment, are defined by the structured environment. Usually, the way that data is captured and managed from that perspective, either is a combination or a limited aspect of timestamp data, or a combination of that. We really should think about it from an environment where the source of data may not be consistent, that the source of data or the types of data may not be consistent, but yet they need to be able to be functionally, and from an analytics perspective, they need to be able to intersect, because that key type of data helps us.
The unstructured data, you mean?
Yeah, the unstructured data or the structured data. It's key to us making the decision about whether it's valid and viable, and then us being able to visualize it. So the visualization aspect is key, so that we can actually stop and see where and how the impact of these different iterations and these different intersections are occurring. Particularly, again, like I said, from a descriptive and a diagnostic analytics perspective.
So moving into kind of how this stuff works, maybe a good example would be, how do you merge, and we'll talk about visualization right now, or you can talk about a different type of descriptive analytics, but how do you merge the structured and the unstructured data? Is this something that's done, or are you doing it separately? I presume you'd want to somehow bring the two sources of data together when you're analyzing it, but maybe talk us through that.
Sure. So the way that that's done today, and really for the foreseeable future, if you look in the Hadoop environment or the big data analytics environment, the sources that feed those high-performance computing environments are all of those varieties: structured data, unstructured data, and basically the role of that capability is to kind of eliminate the unique nature of the data from a real-time or non-real-time perspective, but yet be able to bring all of that data together to make it useful on the outbound side. So if it needs to be sourced from an unstructured and structured perspective, and the outbound side is structured, then that's, for all intent and purposes, the function of big data analytics from that perspective. And many of the tools, many of the analytics tools, and many of the data visualization tools then directly connect to, actually have a software connector to those big data stores, so that they can consume this combination of data and be able to then analyze it and run it through analytics capabilities for visualization purposes. That includes click streaming data, that includes all sensor data, that includes the structured data sources. I mean, all of these things. So that's one piece of it, Bruce. The other aspect, and this is where the dependency on the analytics package comes in. You see this a lot in the business intelligence space, is being able to take not only big data sources, but intelligent databases, relational databases, online databases, social databases, cube data, and then being able to pull that together and whether it be a join or whether some type of combination of pulling that data together, so that at that point all of the metadata is available. And the iteration of that data could be automatic, to the point where there's some natural intersections of the things that make the most sense to work together and to be captured. And then there's the human aspect of that. And that's really where the data visualization comes in, and some of the business analytics tools that you see out there today. They're very focused on that human interaction and kind of coming to the story behind the data. And that's really, at the end, through all of this, that's really the end result. If we can use data to be able to tell the story, as opposed to manually rifling through hundreds or potentially billions of rows and columns of data at any situation. If we want to know what particular sensor in an IoT environment or a particular person is, and join that data with their physical location, maybe some geo information, some GIS information. We need that ability to be able to have that level of visibility at the analytics level, and then being able to visualize it.
Yeah, and I think you bring up a good point. And in particular, just using this example of bringing in different sources of data, whether they're structured or unstructured. But I think what you're saying, if I understand it correctly, is in some cases, in the case of visualization, you're going to bring these different data sources together and you're going to visualize them independently, and then you're going to use a human, that being the people, to interpret it, right? And then that would be one class. And then another class is that you're going to bring in these data sources individually and then mathematically represent them individually, and then try to then come up with a mathematical representation or find the relationships between those mathematical relationships where you use the machine for finding or for describing what you're seeing. So it seems to me that there's kind of if we look at how does descriptive analytics work, one way to cut it anyway at a very high level is You have the visualization, which is using the human brain to derive insights. And then you have the mathematical representation, which uses the computer or the algorithms, obviously, to derive those insights. Is that a fair way to kind of characterize it?
It is, Bruce. And you mentioned also the machine aspect of this, and there's a lot of work being done in the machine learning space, the AI space, the artificial intelligence space, that actually is an extension of this conversation. Because once you have the mathematical aspects, the algorithms determined through both the data mining, the data gathering, these initial stages of analytics, then the machines can effectively, through being able to leverage the data, if you will, they can start to share some of these concepts and arrive to new results. And so that machine-to-machine piece here is particularly interesting.
Yeah, no, and machine to machine in this case being slightly different than, say the common definition. But I agree with you. And then even after that, you can then put some visualization on top of the machine collaboration of that mathematical model and use the brain to kind of go from there. So it is kind of an iterative cycle. I think that's good. And well, maybe if we can switch it from the theoretical to more the practical.
Okay.
What are some of the more useful IoT visualization techniques being used today? Is it kind of what we're talking about? Just put a visualization and take a look at it, or is this more, classified or more formal? Is there a more formal way to kind of look at this?
Well, one of the interesting things about the Internet of Things, or IoT, when it comes to analytics, and particularly from a data visualization perspective, is usually the geographic aspect of IoT. So that plays a key role in the visualization piece. And it may be based on where a particular device is, how that device is connected to the bigger scheme of things, whether it's an extension of a network visualization, or maybe even an application visualization that shows how many users have downloaded a particular app and are actually on the network or on the virtual environment using that particular application over an infrastructure. So I would say that the geographic aspect of IoT is particularly interesting. Yeah. And the other thing, and this is kind of goes back to the forensics piece into security, is showing where a device has been. So if realizing that some IoT devices as they're being designed may only live on a network of any size for a small amount of time, I still want to know where that device has been. I want to know, where it's connected, how it's connected, what it used potentially, what policy triggers it kicked off while it was on the network. And all of those things become particularly important in whether it's in a current state, that device may be in a sleep state, or it may be in a state where it's on all the time and producing data. So those are, to give you some perspective, I think those are some of the things that we need to consider here.
Yeah, and now you've mentioned this a couple of times, so I just want to clarify. But you've mentioned where data becomes alive, and then only for a short amount of time, and then goes away. So are you referring to situations where the devices are asleep and then wake up, or are there other things that I'm not really catching here?
Sure. It may be, particularly in the sensor community, where a sensor its job is, as it's designed, is collecting data for a period of time and then going to sleep to save power, or maybe based on power generation or the fact that it produces its own power. Right. Or in the scenario where it's a kind of a lightly connected network device, where it only needs to transmit to the network and then wait for the next command to transmit. So that changes the dynamic, or the traditional static world that we're used to living in, and then it packs everything from IP address schemes to the way that networks perform. Because when that device is connected to the network, it may consume bandwidth. It may require services. It may hit some particular security policies that need to apply when that device is alive on the network, or for it to gain access to the network and to stay there for a period of time in terms of resourcing. So it will challenge, and there's a lot of conversation today in a kind of the network architectural aspect where this is a new class of user for both enterprise, commercial, provider, marketplaces, and just in that profile and the way that the IoT space is heading, the different classification of devices, and it's not only the mobile devices we know today, it is that kind of intersection of sensors and mobile devices and the rest of the world, if you will. It will introduce some new challenges and definitely some new architectural considerations.
Right. No, and that makes sense. And I think you're bringing up, the concept of data coming on and off. But I think at a high level anyway, us being people, we're kind of taking this data into the four dimensions we know, the time-space continuum. So the time being, when it's happening, and sometimes, as we're saying, it's not always happening. And then the space, you were alluding to that being the geographic aspect and where it is. So that's four dimensions that we can get our head around pretty easy. But obviously in visualization, when you start, depending on what you're measuring, you're going beyond those four dimensions. And that's what I wanted to ask you is what are the techniques that are being used? Is it kind of like, I used to be in the business of, I was a programmer that we recreated three-dimensional objects from CAT scans, for example. And then the surgeon could, slice it and look at it in different ways. And then from EKG information, that's another dimension. There's dimension 5 where we could color it, so we have it animated. We've got time with the animation. We've got the 3D. So there's there's your 4D in space, and we put color. There's the 5D. Mm-hmm. Is it kind of that, or is it gone beyond? And heck, I was doing this 20 odd years ago when I was programming, but has it gone beyond that in terms of visualization? I mean, there's 5 dimensions I was just sort of bringing up.
Well, it has, and it continues to head in that direction around creating the more informed and iterative view of the situation. And let me give you a healthcare example. So if you look at some of the healthcare innovation that's in place today on how care is provided and the impact that the Internet of Things is having already, part of it is diagnostic, where everything from the way that medicine is administered to the way that patients are monitored and from a remote perspective, in the way that the interaction of the doctor knowing the state of the patient at that point. So to your point earlier around changing the dynamic from the doctor's perspective, the behavioral aspect, the data that's created, the capture of the state of the patient based on use of technology may be one piece. And the other piece that he's looking at is the distribution of the medication at that point and the potential interactions. And then bringing in an electronic health record or a CAT scan. And, it's that new mashup, if you will, of interaction that really will produce the next level of outcome and help with making faster decisions, more real-time decisions based on the use of those types of data sources.
Yeah, I like the word mashup. I think it's a good one. And then
it really is the new mashup.
Yeah, it is the new mashup. So talking to our audience now, what should be considered when you're in the process of choosing a descriptive analytics solution? Obviously, you need to know what what the data you have and what you're looking for. But let's take it beyond that. What are you considering if you're actually looking at buying a solution, or I guess even making one or stitching things together to make your own?
Yeah, and so great question. As you look at the space, majority of organizations are used to dealing with their data warehouse environment today. They've made some investment in some type of high-performance computing environment or traditional approaches in their relational database space or even as far back as Excel spreadsheets. All of those
still use those babies.
Right. All those things need to be taken in consideration when making a decision about the type of tool, the type of business intelligence and business analytics tool, because of the fact that you need to be able to support the types of data sources. So having the ability to directly connect to those types of sources on a real-time basis are key. And then determining how much of that extract or when you need to extract data on what basis. Many organizations, once they make the decision to go down the path of incorporating analytics, ask some of the bigger questions about really what do we want and how often do we need to see it. The reality check there is they find out that they really need to see a lot of data in real time. So the tool that you choose needs to be able to accomplish those goals aligned with what you're trying to achieve. And there are a variety of packages out there in the market that kind of operate in the traditional legacy BI space, and then some that are more focused, and this includes the data visualization aspect, and some that include more the statistical legacy BI side, and then blend in the data visualization aspect. And then there's one other consideration here is that what you want to use the tool for. If you want to start to use it for forecasting or predictive and prescriptive analytics, then typically you lean toward the more the progressive tools, the ones that are coming from the data visualization side of the analytics model, as opposed to the traditional legacy BI side of the market. So that way it can be, again, it's all about what you want to accomplish and what you're trying to achieve.
No, some really good points here. The first one, just to kind of reiterate, connection and cadence. What are you connecting to? What's the data sources? So making sure your system, obviously, be able to connect everything you need. And I think that comes down to that initial audit when you're trying to find what information you need, therefore what data you need to collect. Cadence, really important. That is how fast the data is coming in. That's going to dictate the architecture, the type of package that you're going to buy. And then another thing I wanted to differentiate is between BI and business analytics. And I think what I interpreted, and I think my understanding anyway, but correct me on this before I have my last question. BI is kind of more traditional, so you're saying statistically oriented, whereas business analytics is maybe a little bit more visual. Is that a good characteristic?
So yeah, it's a good way to characterize it. The traditional and really the legacy of business intelligence came from the statistical view of data, and you still see that today in terms of that tie into the analytics side and the business intelligence aspect. Whether visualization is part of either one of those, because usually in the business intelligence world, visualization is reporting. And we're not talking about reporting here. We're actually talking about representing data in a way that you can make some decisions. You can ask some additional questions. You can see the story behind the data as it's happening in real time or in combinations of real time and past and historical data. That the visualization aspect is key there. That's not a report. A report is designed to be a static thing. So that seems to be right now a departure. That again, another one of those considerations in choosing a package that has those capabilities from an analytics and traditional BI perspective. What really fits your environment.
Yeah, and BI. So, I mean, in a nutshell, how would you then differentiate between BI and business analytics? Is BI just a subset of business analytics, or is there something more to it?
Oh, yes, absolutely. That's a great way to represent it, Bruce. Business intelligence is just a subset of business analytics, and I think if you can define business analytics, it is that blended combination of analytics capabilities, business intelligence. The statistical aspect, and in many cases today, through what you see in the industry, data visualization is a part of those packages.
Yeah, and we're going back to again, human interpretation versus machine interpretation. Yeah. All right. So I want to pick up on something else I think that you mentioned earlier that's pretty important. And it's kind of a chicken and egg question. So, in most cases, we've talked about the different types of analytics in this program, and you've brought them up as well. We have the real-time analytics, we've got the descriptive analytics, the predictive analytics, and the prescriptive analytics. Now, in most cases, you're going to need a combination of one or more, or a combination of two or more of the above. Which comes first? Are you, you know what I mean? Like, are you picking your descriptive analytics program and then seeing, and you kind of, this is what you were kind of talking about as you have it, and then connecting it up to your prescriptive prescriptive analytics system, or are you doing it the other way around, or does it just depend? Or so talk to us a little bit about the priority, what you're choosing first, second, third, and if you know what I mean.
Sure, I do, and so to that point, you need the ability to look both at what happened and what's happening, and that's really the purpose of the notion of an analytics continuum, so that you can achieve all aspects of being able to source data, to mine the data, to source the data, to analyze the data, and then use the data. And really,
good way of putting it.
Yeah, and it starts with the descriptive analytics piece, so that we can really incorporate and figure and determine, based on the data that we've collected, what has happened and what's happening, and then being able then to serve that data forward into the proactive models, the predictive models, so that we can start to look at some of the patterns. We can make some decisions about forecasting and trending. And then from there, the prescriptive piece would be the next logical step, that we can then make some decisions based on what we're seeing. And it's almost in the market, Bruce, as you look at analytics packages, again, as I make a reference, it's usually not separated into pieces. So, like in the world, you don't have to worry about 4 or 5 different packages. There are many out there that actually incorporate and do this entire analytics continuum quite well, and are able to help you source the data and take it the whole way to actually applying the knowledge that you derive from that data.
Yeah, no, makes sense. Okay, so what you're saying, and I think the continuum that you've mentioned a couple times makes a lot of sense: descriptive, predictive, prescriptive. And what you're saying is generally you don't have to make that decision in terms of the order, even though that's kind of the order of the data understanding or the knowledge of that you're gaining from the data, the path that you take. What you're saying is generally this is all together. So then I suppose it would just be you just prioritize the packages based on your priorities.
Absolutely. If you just need to capture data and generate reports, then typically that's the business intelligence solution set. If you need to capture, interact with data, ask questions about data, tell the story of data, and really use it as a means of predicting direction and determining how to affect change in the organization or your particular mission. That's the kind of the business analytics piece and the full analytics packages.
Okay. Well, the last question I'd like to ask, and maybe we've kind of answered it, but maybe you can use it to summarize, is best practices. So, our listeners are in the process of defining their IoT solution. And as they've heard from me many, many times, the analytics is one of the most important components, and one of the components that you're going to need to build your own intellectual property on. But what would be the best practices for choosing these, or for putting descriptive analytics to work, let's say, within the enterprise?
Well, I have to say that as I mentioned at the very beginning, one of the key areas here, and we kind of at times get so focused on the capabilities that get brought forward by new technologies like IoT that we never want to forget about security. So.
Okay, that brings us full loop.
As we're choosing and as we're incorporating IoT technologies, always make sure that security is first, and you're determining the risk of the technology, of and being able to leverage the type of information that's being created by IoT in general. The second piece of that is from an analytics perspective and relative to IoT. It should be viewed as another means of source of data that can be used. And the question is that how are you going to use it? Whether does it affect the social collection of data? Does it affect the way that a particular organization operates? Does it affect the way that you provide services? Or is there a human effect? I think the analytics piece of this will provide those types of insights to really make IoT valuable and useful long term. And really, as a class of user now, it is something that we are considering now, and as I said earlier, a key contributor to architectural strategies going forward.
Yeah, no, absolutely agree. And just to tie it together, to apply your security considerations to the analytics that you're choosing. So what would be the security considerations when choosing your analytics, solution?
So what's key is the ability to forensically see where and how traffic is being sourced, for what reason. Mm-hmm. And traditional security policies, as I said earlier, where the device has been, what it's done, and look at that full forensic aspect. Because we have yet to see data breaches that are created that are sourced from the IoT environment, but as the hacking community continues to evolve, I think that's a very good possibility. So we have to be prepared for that type of reality and make sure that the security policies we have in place both allow the function that the IoT element provides to work, but at the same time also make sure that we're very cognizant of the risk factor and taking the necessary steps to protect and defend against potential attacks.
I like it.
New attack vector, basically.
Yeah, no, I like it, and I think one of the important takeaways from what you just said is when you're choosing your analytics package, make sure that it can capture and then analyze data that's going to be required for potential security forensics, but hopefully even real-time detection as well as mitigation. And I think that's something really important to keep in mind. You're right. All right. Well, with that, Dave, how can people find out more about you and your company, and specifically, with respect to IoT?
Folks can follow me on Twitter at Dave Rubal. I'm very active in the IoT conversation as well as in big data, and as a practicing data scientist as well. And even in my spare time, I work with and visualize all sizes and types of data. So, and from a security perspective, as I mentioned in this new intersection, I also share my views and extend a lot of the conversation around this new intersection of security and data. So that's from a Twitter perspective, and I'm also on LinkedIn. I encourage people to both read my posts there as well as reach out and connect. And I'm also a blog contributor to Blue Coat's federal blog. It's called Federal Blueprint.
Okay.
And it takes on a lot of topics regarding cybersecurity in the government space from a number of different angles. So definitely, please, you can read my blog there and connect with me in any one of these ways. I look forward to it.
Yeah, excellent. No, and I'll put all three of those sources in the show analysis notes for anyone. You don't have to remember it. And I think it is worth checking out Dave's blog. I have taken a look. And specifically, if you're interested in the conversation we're having here, and that is, security and IoT and analytics all rolled into one. It's very important, and you have to keep it always in mind all at the same time. So thanks a lot. I appreciate the time, Dave. It was a great interview, and we'll catch you soon.
Thanks, Bruce.
Okay. That was a good talk with Dave Rubal. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc., published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support the show by buying my book, IoT Inc., or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Predictive Analytics Deep Dive, The Shape of Things to Come, with Anil Gandhi. I hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a descriptive and pivotal one.
You have been listening to the IoT Inc. Business Show.